is an important part of our ability to communicate. Certainly, in many terms of model patterns,
well, you know, about the state prediction, I'd really like to distinguish between two very different concepts.
One is sort of
Forecast.
whatever semantics,
Say something how the
system looks sometime in the future.
The
other one
is
making it,
you know, this is something that to a certain extent is lacking
in
in
geoscience.
geoscience.
I think that
You know, it's making a prediction about how some manifestation of the system is having observed. See, there is a problem.
I mean, in physics, the general concept is that
Theories
never
predicts certain phenomena.
certain aspect of the phenomenon.
Somebody goes
to the lab, small lab, does the experiment and confirms or invalidates the theory. Typically, the geosciences work. It's not how it works all the time. People said data takes a lot of time.
You reproduce this picture, you know, and then
that says, you know, the simpler it is, the better.
there is no way of telling.
There is no way of telling.
So
in terms of let's say that one of these models, you know, hasn't been observed, and then you look oh, yeah, that's interesting. Geosciences interaction
would also be an improvement
of the interaction
more physical way of thinking,
more physical way of
purely descriptive.
purely descriptive logic.
Theory is only served.
Theory is only served to provide coherence. I'm overdoing it.
But I think the other point is important. Geoscience. One of the reasons why geoscience, maybe in the white paper, this is something that should be emphasized, is geoscience is pretty messy. Geoscience is pretty messy. Geoscience provides, in some ways, geoscience provide a good test bed for wildlife. So the reductionist spirit that near to us probably near to our hearts is sometimes hard to carry very far. The point is, geosciences provides a lot of really challenging problems. They provide interesting challenging problems. They provide mathematicians. So I think it does represent an attractive venue for mathematics. An attractive venue for mathematics, say, astronomy, or other fields. And so maybe in this white paper, what needs to be justified is why maybe this white paper, what needs to be justified is this geoscience, the appropriate part of math, physical science needs to be addressed. I think there are actions. Some of these are the arguments. So I think that needs to be addressed. I think there are rational reasons to make the arguments. At the heart of it, I suspect, is that geoscience is complicated, and so it makes these very simple reductions to experiment proving not so clear. It is very much. There's no question that you can make a prediction before it's true. It carries enormous weight. The supervisor always used to say, anybody worth their salt can find something after it's been observed. The trick is actually explaining it correctly or anticipating. And that's just it doesn't happen very often in science.
Well, I'm afraid that it happens and people don't recognize it.
Very true. I think they're they're yin and yang or opposite sides of the same coin. We can't get rid of the same as the light difference. Put around the home and etc. The way physics works is, if it's complicated, they can't handle it because you call it engineering. So, friction or fracture, anything you can't handle in very reductionist way, say, oh, that's too complicated. Whereas the geoscience method being defined around a subject, then you say that all phenomena associated with climate or earthquakes or whatnot are the subject, and hence, so it does tend to promote this very sort of pragmatic, very phenomenological approach, and obviously this is what's the great attraction of this, like the advertises this, they are much less prone to that sort of approach, and much more prone to sort of explore a lot of alternatives we can for this immediately useful. So I think both statements are true, and probably both are right. Try to emphasize it.
I think it's ready.
Okay. No, that's just a VLC. Okay. Yeah, but it doesn't do it in version. That's a very poor version.
We always switch to more
Yeah, okay. It's supposed to be in my style. It's supposed to be standing up under the green sideways, so I should have gone. And let's see. Okay. So what you see basically the roles of and you see two kinds of motions. One is really the invariant measures affected by the flow of the but you can sort of see a jitter, which is really interacting on the noise. And the interacting noise and the noise. So, the thing that I only went through very quickly, the case of the interacting resonance of a couple of circle graphs showed what happens just in terms of smoothing, where you have additive noise. Here you see that the mobility has variation ionization, which accounts for making it for the rough behavior, the bound independence that I showed for the functions. In any case, I'm sorry that this is practice with that because this is very available. But it's, as far as I know, the first time that anybody has shown with such a high impact that really looks like and it is surprising. It's much richer. I mean, quite honestly, I always thought of the effect of noise on 3D track as smoothing, instead of having the fun onion skin structure, you just have some sort of Gaussian support on it and so on. And this is not at all what happens when you noise. And again, the idea of using additive noise just has to do with the fact it's the lamppost. It's a story that I'm sure most people know about the guy who gets home and sees his neighbor on his knees and that's what's going on. So he lost my keys, so it's nice. He also gets down on his knees. He doesn't find keys anywhere than the other guy. And that's where did he lose them? Over there, right? You can hear this in your lamppost. People use additive noise because it was easy. Okay, but it's not the natural thing. Really. So anyhow, thanks very much for being gracious.
Okay, any other comments from the...
Incidentally, the movie is a supplementary information on one of those papers that I indicated, which is paper in physical heat. The author Michael Chikun and with Eric Simoni and myself, and Princess McGee, that the movie, living color is on supplemental information.
I wonder, Michael, have a comment on
What's your name?
Tony Song from KPL. Talk about the IPCC prediction of the climate change. So, what's your opinion? So we need more data, or we need a better model? So what's
Well, I don't know whether this should go into the white paper or anywhere out of this room, but my opinion is that one thing that we don't need any more of is assessment reports. The first assessment report that was published in, 1991, lead editor John Houghton was great, because it really summarized the knowledge, and it was very important. The subsequent reports are the results of the Rio Agreement. They're dictated by that impronounceable acronym, basically the Rio Convention that says you have to do these assessments every few years because, countries like Saudi Arabia don't want to cut off hydrocarbon supplies. And so, this has come to rule the field more and more. It has engaged more. It has provided to some extent resources, but it has asked for an enormous amount of work, which is ill-timed because people, look, I was for many years the chair of the Scientific Advisory Committee of the Climate System Modeling Program, and of course I'm in contact with other groups. You have to, there is some sort of a natural way in which you want to freeze your model when you think it's right and do the experiments you think they're right, and not on the schedule dictated by these IPCC exercises, which ask you to freeze much too early, to not have the time to analyze the runs quite the way you wanted. So I think that although we've certainly learned a lot of things out of these, they are becoming more of a hindrance than progress. But this is my personal opinion, And no, I do not think that temperatures are going down. That's not the point. I think they're going up and they're contributing to it. But, it's not this way. There was an interesting essay in a Nobel volume that commemorated the Arrhenius paper, I think, on carbon dioxide. And there was a Dutch sort of philosopher and historian of science who wrote something there about small science, big science, and mega science. In the 19th century, there was small science. You went into your basement, you did an experiment, talked maybe to the neighbor, the communication academy. Then there came World War II and big science and so on. Now we have mega science. On the one hand, you have these high energy physics papers in which the list of authors is longer than the content of the paper, and on the other hand, you have the IPCC reports. Okay, I was honestly shocked. I don't know how many of you went onto the website, the IPCC, as the AR4 report were published. There were live linking. It said 972 people, 1,577 pages. What? One report. What? Are we selling underwear or what? I honestly thought it was embarrassing. And while individually, I think Susan Solomon is a hero. She made a really important contribution in going in a very sound and honest way about it. But a lot of the politics of this are really embarrassing. Of course, the opponents are even more embarrassing. People like Claude Allegra and Patrick Michaels and so on, even more embarrassing. But that blinking on the website is not a good sign.
Okay, I think we're...
No, we're talking about the politics.
No, I said,
How can we improve our model? Do we need more data or do we need better mathematics?
we need both. I mean, we need both. Look, I don't really think that there is such a thing as too much data. You know, there might not be enough time to analyze. Okay, I mean, again, since you're at JPL, you know well that in principle, NASA missions are supposed to have 10% of the budget dedicated to analyzing the results. And well, I heard already people laughing. You know, yeah. Rather JPL person in the back, you know. I mean, those 10% always get eaten up by the next mission. You know. So, you know, there isn't, there's always information to be extracted from more data, but I definitely think that we do need more mathematics. You know. And statistics and, you know, data mining and various other sophisticated ways. Things. I mean, that's what I was saying in my second slide. That more computers and more satellites don't mean less mathematics, they mean more mathematics.
The flip side of that, too, is that as the solutions get bigger, it actually gets harder to mine through these numerical solutions to figure out what's in there. So in addition to these data sets, which are observations, in some sense, the numerical models increasingly present a challenge in terms of analyzing the data. So there's, I think, enormous opportunities for a group like this to sort of tackle and some of those problems.
I think the only thing I would say that to conclude would be it also behooves us as geoscientists to come up with tractable problems. Some of the big problems may be so difficult that no matter how you put about mathematics, you're not going to make headway. So somehow we need to identify those tractable problems which can be attacked by modern mathematics. But let's thank both of our speakers and take a coffee break.